Introduce the astrogator, John. Yeah, John is the CTO at Space Explorations Engineering. He's an astrogator, so that means he's an astro-navigator. He analyzes spaceflight missions, designs trajectories, estimates orbits, planning maneuvers, and develops software. He's worked on several cislunar and lunar missions, including the NRL/NASA Clementine lunar mission and NASA lunar-resonant mission, IBEX, the NASA LCROSS mission, lots of acronyms there, that impacted the moon, the NASA LADEE mission, which orbited the moon, the SpaceIL Beresheet mission, which orbited and then attempted to land on the moon, Rocket Lab's lunar Photon CAPSTONE, and the Korea Pathfinder lunar orbit KPLO/Danuri, which is now orbiting the moon. John currently supports a variety of other missions ranging from low Earth orbit to deep space, including several upcoming lunar missions, and teaches training courses in trajectory design, mission planning, and orbit determination. So hopefully I pronounced all of those acronyms correctly and said that all right. But yeah, how's it going, John?
Sounds good. You did a great job.
Where are you calling in from?
I'm actually down right now at Virginia Tech in Blacksburg, Virginia, visiting my daughter and going to give another talk to some of the aerospace students tonight.
Awesome. Well, I guess as we get started here, if people want to share the space to reach more people, or if they have questions, just leave them in the comments, and we can also bring people up on stage as well if they'd like to ask questions directly. But yeah, so I've got a number of questions here, but I think I want to start with just like a big high level one, which is why is space exploration important to humanity? So like zooming all the way out, what inspires you to work on this stuff? What gets you out of bed in the morning?
Yeah. So that's a great question. For me personally, it's just something that has always been part of my life since I can remember as a kid. I grew up during the Apollo age, and so was watching the Apollo missions launch and the landing, and that was very inspiring to me. I'm also a big science fiction fan, so I've read lots and was always dreaming and watching Star Trek and then Star Wars, just always thinking about space and always wanted to contribute to it. It was hard to figure out how to contribute to space. We can talk about that a little bit later, but it was just love looking at the stars, loved astronomy, took astronomy courses, was fascinated by rockets, studied rocket propulsion even like in high school and did model rockets in junior high. So it's just always been a part of my life. The reason I think it's important is I think it's a never-ending goal for humans to go, so that we're not just constrained to this Earth. There's always more to learn about space, robotically and through remote sensing through telescopes, and then in situ measurements where we send probes and then eventually send humans. And I think that's just part of human nature, is exploration, finding out from where we came, finding out how the universe works. I definitely could keep going. So I'll stop there.
Yeah, no, I think we at Munda we share that same passion and perspective of trying to learn more about the world through space exploration. I'm curious. So what in the lunar missions that you've been involved in, what did they teach you about the moon and space in general? What was something that came up in your own explorations?
Yeah, so there's been a couple things. So going to school and studying it and going through textbooks was all interesting. And then when I started working on actual missions, I was a contractor at NASA Goddard. My first mission was the Deep Space Program Science experiment was a combination between Naval Research Lab and NASA, and also known as Clementine. When we started, we won the contract, and then 2 years later we launched. And we had done all this theoretical work to say that we could fly it. When we won the contract at NASA Goddard to fly it, we had to, put our money where our mouth was, as it were, and then really started building hardware, really started working on when we would launch, exactly when the maneuvers would be, how are we going to track the spacecraft. And then we launched, and we're doing the same calculations and sending the commands up to the satellite and telling it when to turn its engine on and off and for how long and what direction to point in. And all of a sudden it just became real, and it became something that, you could it felt like you could reach out and touch. It's like we're really doing something. And I remember going out and looking at the moon and thinking, wow, we using calculations that I learned in college, where you put some metal that's now orbiting space, and it became very visceral. All of a sudden I knew what was important in the textbooks and what wasn't important. And it was just exciting. And our whole team, it was a huge team effort. And it was just really cool to be part of that.
Totally. I'm curious if you could maybe break down what astrogation is, or how, like, if you could provide a layman friendly explanation of how trajectory design works, and the work that you do.
Sure. So first of all, the word astrogator comes from science fiction, apparently just like the word astronaut did. So people had talked about it for years. I learned about the word from some friends, fellow astrogators at NASA Goddard, and from some of Robert Heinlein's books. Although I think the phrase was around before that. So like you had mentioned ahead of time, it's navigation to the stars. So the first thing we have to do is find out where the spacecraft is. So we have to track the satellite. So there's different ways to track satellites. Satellites that are in low Earth orbit, a lot of them have GPS, and they telemeter their position and sometimes velocity back to Earth. And then we fit an orbit to that. The ones that go above the GPS constellation, we have to track using radio frequencies. And the primary ways that we do that, if they're close to Earth, is we look at the angles where they are, but we also look at the Doppler shift in the radio frequency. And then we also can send a message and have the spacecraft turn it around. And we know the speed of light, so we can calculate the distance or the range. And so we get these range measurements, we get these Doppler measurements, we get these angle measurements, and we fit an orbit to it. So that tells us where we are. We know where we want to go, because that's why we're flying the spacecraft. And so then we take where we think we are now, and we calculate a series of maneuvers, which we call a trajectory. We calculate the series of maneuvers, which will take us from where we are to where we want to go. So like on my first mission, we launched into low Earth orbit. We wanted to go to the moon. So we wrote some software, and we calculated when we should fire the engine to leave low Earth orbit and head towards the moon. We had to do a couple maneuvers on the way there, because we didn't launch directly to the moon. We went into some big loops in the cislunar space, and we fired the engines periodically. And then when we got to the moon, when we got near the closest approach to the moon, we did a large maneuver and fired the engine opposite, a retro maneuver opposite the velocity vector, and captured into lunar orbit. So what an astrogator does is you track where you are, and then you calculate the series of maneuvers to get where you're going. And then some of the side things that we do is we calibrate the tracking stations, and we calibrate the engines and other housekeeping issues to make sure that when we go forward, we can still keep tracking, and we can still keep doing maneuvers. The other thing we have to do is we have to take the predicted orbit and give it to the ground station, so they know where to point the dishes, because we can't do anything if we can't talk to the spacecraft. So that's a hugely important thing to do, is point the ground stations in the right spot of the sky.
Yeah, that makes sense. I'm curious, from the time that you started working on astrogation, what have been some of the evolution of the technology? So, like, are things a lot easier now? Has there been new software and tools that you use that have made your job easier? What's sort of the progress in the space been like?
Yeah, so like I mentioned, I started at NASA Goddard, and one of the first programs I worked on, there were a group of us. We were assigned to take the um, software that they had been using already successfully on the mainframe computers, and we were told we're going to start using these new personal computers, which were all the fad at the time. This is in the late 80s and early 90s, last millennia. And so we started putting things on the personal computer, and we had some very tough missions that we had to design. We had to design some missions to libration points, Earth, Moon, and Earth, Sun libration, or back then Earth, Sun libration points. We had to design missions to the Moon. We had to do gravity assists of the Moon when I was at Goddard. And so there were some experts there. One particular guy, Dave Dunham, was really good, and he led a team doing this work. And we tried to figure out on the PC how we would do that work and make it faster and enable more people to do the work that he and his team could do. And we tried a couple of things. We tried some artificial intelligence and whatnot, but the thing that became really good was doing interactive graphics. So we started graphing the trajectories to give the feedback to the astrogators, so they could see where they were going, see where the trajectory was going. Um, it's kind of like it's fairly easy to balance a broomstick on your hand, even though it's very nonlinear and very chaotic. When you can see and feel it, when you can see and feel the trajectory, humans are really good at picking up the first and second time derivatives and the spatial derivatives. They're good at looking at curves. And a lot of these curves in the Earth, Moon, Sun system, we don't have simple numbers that describe them, but a human can pick them up. So we started mixing these numerical algorithms with graphical feedback. And I think that caused this revolution where we were able to get lots of folks to be able to do these trajectories. So, of course, now we call that data visualization, but it was very experimental when we were doing it with trajectory design originally. And we still do that. We still do things that same way.
Yeah, that makes sense. Yeah, being able to visualize it seems very well. Yeah, I guess if you're trying to describe those curves in numbers, it's almost impossible to I don't know, gain an intuition behind it. But then seeing it visually, yeah, that makes a lot of sense.
Yeah, it reinforces you develop mental models that I don't think you get by just looking at the equations. And then you go back to the equations, and then combined with your mental model, I think you can gain a deep understanding and intuition, which helps you become a better trajectory designer.
Definitely. And so I guess speaking of trajectory design and lunar missions, we've seen a number of lunar missions that have crash landed on the moon, and I'm
Mhm.
hoping that you could break down some of the challenges when it comes to lunar landing, and why is it so difficult? Why have so many different groups have had issues with it, and how can you mitigate those risks maybe?
Yeah, yeah, that's a tough thing. So, first of all, it's hard to leave the Earth and get to the moon to begin with, but we've got quite a bit of experience doing that. And the way that we um, go from the Earth to the moon, as I described, is we have dishes that track the satellite. We then are in the control center, and we process it. We calculate the orbit. We figure out where we are. Then we send the command back up to the satellite. So it's kind of all open loop. And this takes on the order of what I just described, say, takes an 8-hour shift to do. Then when you get to the moon, at some point, you have to hand everything over to the spacecraft that's going to land, because the way that we typically do things is we go into a lunar orbit, takes about 2 hours to go around the moon. At some point, we issue the final command to lower the periseline. So let's say we're typically in a 100-kilometer altitude orbit. We lower the periseline to say 15 kilometers, which is normal. Spacecraft approaches 15 kilometers, then the spacecraft is on its own. So we can't babysit it anymore. So all the human knowledge that we had has to be embodied in these algorithms that have to, in the next 10 minutes, have to work flawlessly. And so there's been a lot on the web about the problem with the Japanese lander, where it looks like when they changed the landing site and the lunar terrain, not all of that got configured the way they had wanted to. And so the spacecraft went over a cliff. It thought it knew what its altitude was as it was landing, thought it knew what its altitude was, but it didn't. When it went over the cliff, all of a sudden the sensor said you were a lot higher, and it thought it was bad data. And so it was quite a bit higher than the moon. And so it started landing, but the moon's surface was kilometers below it. So, and similarly on Beresheet, the IMU, there was one IMU that wasn't working and another one that was working. And when they went to restart the one that wasn't working as a backup, that caused a series of failures, it sounds like, that ended up rebooting the spacecraft as it was already, trying to land, and there just wasn't enough time to recover. So the challenges is getting this robot to handle situations that, if you were a human and you were looking out the window, no room for error. And so I'm super proud of Beresheet, super proud of the Japanese. They got into orbit, they started the landing. That was hard by itself, just getting into orbit. Not a lot of folks have done that. And getting it to land is a lot of work and requires a lot of testing. We have lessons now. We learn those lessons and try to apply them to the future missions.
Yeah, and speaking of future missions, what are some exciting upcoming lunar missions that everyone should keep an eye out for? Yeah, what's going on right now in cislunar space? That's exciting too.
Yeah. Well, so two of them. The Astrobotic company in Pittsburgh is going to be launching before the end of the year. They're going to be launching their lunar lander, and then Intuitive Machines from down in Texas, they're going to be launching as well. I'm not sure their launch date actually, but those are both commercial companies that have got contracts to deliver payloads to the moon for NASA, and also some other commercial groups that want to have stuff delivered to the moon. I think DHL is one of the sponsors for Astrobotic, and they've got a payload on there. And I went up to Pittsburgh and saw the spacecraft, and it's got a little rover and everything. There's a whole museum if you're in Pittsburgh, the Moon Museum there at the Astrobotic Control Center that the public can go into. So those are very, very exciting. And then I'm also excited about the human landing and the NASA HLS program, and that's going to be in a couple of years later. But I'm very excited to see humans back on the moon.
Absolutely. Go ahead, Rod.
Yeah, I just want to say that, guys, let's pray for Astrobotic. There is a payload that I was in charge of installed on this lander, and I really hope that it will land.
Oh, that's cool. Which payload is that?
I actually it's just a small artwork, aluminum plate covered in laser gold. I was in charge of developing the first working rover for the moon, so we should have there a small robot. But unfortunately, we're because of the war and a lot of other issues, so we had to put on pause the project and deliver just an artwork. But I know all the procedures and I can repeat it one more time. So really looking forward looking forward for the launch, and hopefully at some point in time I'll be able to participate in more similar missions.
Oh, that's so cool. That's really cool.
Yeah,
Yeah,
good
that's
luck with
one
your payload.
one of the things I like about these commercial missions is it's enabling lots of different people to participate. And that's really cool because for years it was just the government's going, and now we're seeing that, other folks can participate.
Yeah, absolutely. Yeah, we've even partnered with another group called LifeShip, and you can actually send a small microscopic piece of yourself onto the moon. You can send your DNA to the moon, and that's like it's cool that just for like the cost of those things are $100 that you can literally be on the rocket. Um, albeit a very very tiny piece of you, but still you, right? So
That's
that's
right.
pretty cool. Yeah. So I also want to discuss, I guess, beyond cislunar space. Are there any missions that you have uh, particular interest in, or thinking about, any other ambitious missions to other celestial bodies or deep space, and anything that makes them particularly challenging or interesting from an astronavigation point of view?
Yeah, and my friends and I talk about this all the time, and different people have different things that interest them. For some reason, I'm just fascinated with moons around other planets. I don't have a good reason for it. I just am. I was disappointed when some of the missions to Mars's moons didn't work out. But right now, we're talking about the Europa Clipper going to Europa, and then there's Dragonfly, I think, going to Titan around Saturn. Um, there's, I think, a private Yuri Milner's Breakthrough, I think, are proposing to go to Enceladus. And those are the ones that just fascinate me, both from an astrodynamics point of view, because you have to um, rendezvous with something orbiting a planet. So it's not only go to the planet, but rendezvous with something that's going around the planet. Like the Galileo mission fascinated me as it did all those flybys. That the guys at JPL were amazing doing that. Um, but also the fact that there might be life or conditions that support life and strange chemistry going on in some of these moons is just awe-inspiring to me. I'm just curious. I want to know what's going on there and what we'll find out. Um, I don't know if there is something there or if there isn't something there, but I think personally, right now, the current understanding is that there's a transport system between Mars and Earth. With if something impacts Mars, for instance, it can knock a meteorite off, and it can eventually land on Earth. And I've down to the Smithsonian and seen the rock and touched it. And so that if we find life on Mars, it could be came from Earth, or life from Earth came from Mars. But if we found life at one of the moons of Jupiter or Titan around Saturn, that would really make you think, because we don't know about the transport mechanisms. Those are a little harder to believe. So that might be an early indication of what's in other solar systems. So that's fascinating to me.
That's super interesting. Um, yeah, maybe a far out question, but yeah, what like if from an astronavigation point of view, do you think that it is possible that life came to Earth from one of these sort of rogue asteroids that came from another celestial body? And maybe the question I'd like to pose is, uh, given, I guess, the mathematics of astronavigation, are there any particular candidates that really stick out in terms of like ease of something moving from one planetary body to another?
Yeah. So a lot of the asteroids that we see right now are the ones captured around in the sun, or in the sun's system, that are orbiting the sun. A lot of them near Earth and between Earth and Mars. So and there's a whole bunch that are potentially hazardous asteroids, PHAs, and I do work with the B612 project, which is a really cool project that's trying to categorize and identify potentially hazardous asteroids and propose risk mitigate, propose mitigating methods to protect the Earth. So if those were to have components of life, right, what we just recently saw with OSIRIS-REx is, a lot of carbon and a lot of other chemicals that are building blocks for life. So those are interesting. The ones that come from other solar systems, I think there were 2 of them so far, and they might be coming in a lot more, but we've actually detected and tracked 2 of them coming in from interstellar space. Those are more interesting in terms of what's on those, but they come in so wicked fast. We don't have any samples, and we barely have spectroscopy on them, so I really have no idea what they're made of, or if they would carry that. I don't know if people have proposed that maybe if we're on the ready with rockets, we could intercept one sometime, and so those would be interesting. But at this point, it seems like there's so much we don't know. So I hope we do have more research in those areas.
Yeah, definitely. Yeah. What are the speeds of those? Those I guess asteroids that are coming in from other solar systems. I'm
Yeah,
curious.
they come in hyperbolic. So I forget. I thought one of them was it 60 kilometers per second? I can't remember. I have to look it up. But they much faster. So the Earth is going around the sun at like 30 kilometers per second. And then when we are orbiting the Earth, we're like at 7 to 8 kilometers per second with respect to the Earth. And then to go to the moon, you need to get up to about 11. And to go to Mars, you might want to go to like 14 kilometers per second or something. But these come in way faster, just really so fast. So it would be a challenge to navigate to one of them. You would have to have a fairly hefty rocket. You have to get the timing correct as well. So it's not something we can't do, but
yeah. What is the fastest that we've ever gotten a spacecraft to move at? Yeah, I'm curious. Can we even achieve those speeds today?
Yeah. So for a long time, the New Horizons was the fastest rocket that had left the system. And what was it? It was just like, it was real quick to get to the moon. I forget, but yeah, I don't, that's a good question. I haven't done those calculations to see what it would take to intercept an interstellar asteroid. That we should take a look at that and then post this on the channel as a follow-up. That would be a fun calculation to do.
Yeah, excited to see it. Okay, yeah, I'm also curious. So, what advice do you have for young people that aspire to pursue a career in space exploration or astronavigation? And what advice would you have to someone kind of just curious and wanting to take the first step on that journey?
Yeah. So to participate in space exploration requires people with all sorts of backgrounds, and it's really requires people to spend full time being experts in their field. So the path that I'm on is this astronavigation path, or we call it flight dynamics and mission design. It goes by a lot of names, and for us, having a background in math and in physics or engineering, and then knowing how to program really helps. Not everyone does, but some people do. But then there's other people who just concentrate on software development, and I work closely with those people, and they're experts in software development. And I say, this is the algorithm that I need, and then they implement it and get it working on the computer. Now we're going to Docker containers and doing stuff in the cloud. So in our company, we've got software developers and we've got engineers. And my background is physics, actually. But that's just a small section of space exploration. There's people who are experts in building rocket engines. Other people are electrical engineers and experts in radio communications or designing antenna dish or life support. Yeah, expert in just how do you purify water. And so my understanding, what I had read years ago, was prior to the space age, a person, when humans tried to do something like build a bridge or build a steam engine, there could be one person who kind of knew it all and told other people what to do, but kind of understood everything. And when we started trying to go into space, all of a sudden we needed to invent system engineering, where you had all these experts that may never even meet each other, and they all have to work and design mechanical systems that will actually work together and fit together, and then put that on the launch pad and light a fire underneath it and shoot it into space. So I don't think it's an understatement to say, with practically any skill set and what you're passionate for, if you can apply yourself to become an expert in that, it's very likely there's a career for you in the space exploration field. Graphic design is huge. We have to communicate so many things to all these other folks. In my world, I design a trajectory, and then I have to communicate that to the principal investigator who designed the payload. And I have to convince that PI that my trajectory is going to work, and I have to show that graphically. And it has to be accurate. So there's a spot for artists as well to help in the communication. And a lot of the classes I've taken have been in, and some of the books I have been in design, in both communication and then designing software, the aesthetic appeal of the software, so that it doesn't trick you into believing something that's not right and doesn't trick you into pressing the wrong button. So again, something we could talk about forever. But I would say, if a person wants to be involved in space exploration, find something that you're passionate about, that you can really, like you had mentioned earlier, cause you to get out of bed, and then see where does that fit in space exploration. But there's openings. If you're in the STEM area, no matter what your expertise is, I would give the advice is to learn how to program, because that always helps. Even if you're not a full-time programmer, that always helps. It also helps to take design courses and communication courses and writing courses, because you can be the smartest person in the world, and if you can't communicate it, that's like the proverbial tree falling in the forest and no one's around to hear it. Does it make a noise? You can invent something, but you have to communicate it to other people. Again, another topic we could talk about forever. I'll stop there, though.
Totally. Yeah. No, I mean, yeah, I think it really is worth emphasizing, though, that there are just a ton of different roles available beyond just engineering and physics when it comes to space exploration. That's something that we try to communicate a lot to people. It's like, hey, you don't have to be a massive, big brained physics and just like crazy engineer in order to get involved in space exploration. There's a lot.
Oh, I saw this news article. I live in Maryland. This news article, this woman in Maryland, her job was to go to the grocery store, go shopping. Then she cooked all these meals. Then they wrapped them up, put them on in the I guess it was I guess it's Northrop Grumman now. We put them in the Northrop Grumman vehicle and they ship the food up to the space station. And she's just going to the grocery stores in Maryland, buying food and cooking it, and feeding astronauts. It was the coolest thing. I like to cook too, so maybe that's why I thought it was cool. But I just thought, wow, what a cool job.
Yeah, that's awesome. I feel like hopefully that grocery store knows that its groceries went to space.
Yeah, I wonder.
I'm curious to hear your perspective too on international collaboration on space missions. Our community comes from all corners of the world, and something that makes it a little bit difficult sometimes to collaborate are a lot of the ITAR regulations, and space technology being a dual use technology, you know, it's sometimes tricky to collaborate with other people from parts of the world. I'm curious, you know, what your take is on that. You know, you have
Yeah.
people from all corners of the world, you know, look up at the moon, at the stars, and are inspired and want to get involved. But a lot of countries don't have, you know, space agencies or anything like that. Yeah,
Yeah.
I'm curious. You know, do you think that it's you know it's well, I don't know how to phrase this, but how do you think we can increase international collaboration, even with maybe countries that we might not get along politically, but maybe space is something that could bring the two cultures together a little bit closer?
Yeah, and I think there's a lot of evidence that that has happened. Just even the U.S., Russian, and just so many other countries working in the space station has been amazing. As a kid, I remember watching the Apollo Soyuz, you know, and you know the Soviets and the United States weren't getting along at all, and yet they still were able to do that. ITAR issues are a thing that you have to live with. A lot of other countries that we work with, their countries also have versions of restrictions. So countries have made that choice, and whether we like it or not, we have to live with it. But it turns out that, you know, at least in the United States, you can follow the processes and you can uh, work with the U.S. government and get permission to work with other countries. So you know, I've been in a lot of projects where we've done that, and then a lot of the stuff though does a lot of the important stuff actually doesn't fall under that. A lot of the we've known how to go to space forever. We've known how to go to the moon and land on the moon forever. Really, the challenges are nowadays are sometimes just economic. So that in order to get things or get a payload, um, you know, onto another spacecraft, that's meeting people, that's working with people, figuring out the economics of why you're going to do it and who's going to fund it and how you're going to do that. And that's something that, you know, we do internationally all the time anyway. And universities have always been able to do joint research. And so much of the work comes out of that joint research. So I think there are a lot of opportunities, and I think the ITAR specific issues might just be on some particular hardware subsystems and things like that. But I actually think that's kind of a small part of what's keeping us back from space exploration. The things that keep us back right now um, are usually economic, um, convincing people that this is a worthwhile endeavor. One of the big challenges that we all face in the space industry is people say, well, why are we spending the money in space? Why don't we spend that here on Earth? And so understanding what we do in space that can benefit people on Earth is huge. And it has to be international. That has to benefit, you know, the entire world. I understand how one country would want to benefit their citizens, and yet with international cooperation, we've demonstrated we can do a lot more than just benefit one country. So, so it's something we have to deal with, but I don't think it's a major challenge. I think that the challenge is giving the opportunities to people, research grants, and again, because it doesn't have to be space. Someone invents a new way to purify water, that's going to help, you know, a country that is figuring out how to purify their water for their own country, but it also might be the same technology that helps a person on a new commercial space station. So I think there's a lot of opportunities, and we just have to look for them. And really that's where innovation comes from, is looking at kind of existing things and coming up with new applications of those existing technologies. And a lot of those technologies are not controlled at all.
Yeah, absolutely. I think it's really important to highlight how big of an impact the technology that we've used to go to the moon has changed life here on Earth, and in solving some of those huge problems that you know, inspired some of the world's best engineers, and has translated down to huge economic impact here on Earth. And yeah, I feel like if that could be better communicated to people, then I feel like we'd see a lot more funding going into these really hard engineering problems. I see Rod, you've got your hand up. Do you want to go?
Yeah, I want to add that one of the reasons why I was fascinated by the AstroCool project. Um, it's scary for people, but from PR perspective, maybe it's quite good. But that's a really massive lunar exploration that benefit everyone on Earth, and it would be great to have more projects like that, at least on the ideation stage, that directly benefit in each and everyone, and that directly touch in each and everyone.
Yeah, I think there's a lot of potential for things done in space to benefit people on Earth. And the amount of money spent on space is actually fairly small compared to other things we spend money on. Um, so a lot of it is communication, but a lot of it is also looking for opportunities too. And seeing, okay, for this investment, we'll have a return, and whether it's a financial return, so the person with the money is looking for a financial return, but they're also looking to do things that are worthwhile, and figuring out, is that a scientific return? Is that, as you mentioned, astrocool, is that cooling the planet? Is that creating some new medicine? Is that creating some new uh, mechanical device that can't be created, can't be created on Earth, but will then be brought back to Earth and then used?
Definitely, or long-term settlement. I think that there's also people that see the moon as a blank slate, for an opportunity to kind of reinvent things a little bit, and I think that's also very exciting. Do you think that lunar settlement is going to be possible within maybe the next couple decades? What is that something that you're curious about, or you have interest in?
Oh yeah, I mean, growing up, when I saw the movie 2001: The Space Odyssey, I was always calculating at how old was I going to be in 2001, and would I, be able to go to the moon? So that's been a permanent part of uh, my thought process. Yeah, and I'm just going to maybe exaggerate a little bit, but I think it already is possible today. I don't think that there are huge insurmountable technical logical problems. There are a lot of economic problems. There are a lot of supply chain problems. Those are things we can solve. We kind of know how to do it. We're going to have to get better at life support system. As I mentioned, purifying water is going to be tough. A little easier on the moon than the space station. I guess gravity really helps, from what I understand, in the different water purification methods. So there are technical challenges in keeping people alive in such a harsh environment. But I think they're well within what our current technology and understanding is. But it's mostly engineering, and not only engineering how to do it, but making it so it doesn't cost that much. And then how do we, the trade-off, do we ship things up from here, which is really tough because we live on a planet with so much gravity, or the exciting thing for me is, as we do this lunar exploration, finding out what materials are there. I guess one of the big questions is how much carbon is on the moon. And I've seen a lot of stuff about how much water really is on the moon. You mentioned I worked on LCROSS, I worked on Clementine, worked on LADEE, and we were looking for water on the moon. Finding out what the resources are there, and then what can we do with, in situ resource utilization. Can we make bricks? Can we make glass? Can we make oxygen and hydrogen, for either drinking water or for breathing oxygen or for rocket propellant? So those are the exciting things to me. Is I don't think that there's any new physics that has to be done, but there has to be super clever engineering and super clever supply chain development, and um, financing and, figuring out how can we do it within a given budget. But yeah, I'm very excited to see humans permanently, on the moon, just like we've been permanently in space for a long time at the space station. I want to see the same thing on the moon.
Yeah, absolutely. I wonder. Well, yeah. So you mentioned like economic challenges often, and I'm curious. What solutions do you see for stuff like this? I mean, yeah, we could lobby the government to move more money into space exploration. Maybe we can convince more venture capitalists to put more money into space for financial returns. I guess what do you see as a possible solution to? I mean, it seems like people from all over the world want to see this happen, but
Yeah.
who's putting up the money?
Yeah, exactly. So I mentioned I live in Maryland. And an interesting thing about Maryland is that's really where they tried to open up the Ohio Valley, back in the late 17, early 1800s. And so I think it was July 4th, I think it's 1828, where they were laying the cornerstone for the B&O Railroad in Baltimore, Maryland. And they were betting, there's a bunch of people betting and investing on the Baltimore Railroad, B&O Railroad. And then there was, at the same day, there was a group of folks down in Georgetown in DC laying the cornerstone for the C&O Canal because other people bet on that technology. And this they met at Point in Rocks, Maryland, from what I understand, and the railway always beat the C&O Canal. The C&O Canal, by the way, is a beautiful place for biking and hiking now, but the railway was more efficient. But at the time, on July 4th in 1828, they didn't know which technology would be better. So one thing to learn from that is, well, we might have to bet on a couple different technologies. The other thing, though, is that both those technologies were looking for economic return. So what we need in space, I believe, is economic demand. There's plenty of supply. We know how to do things. We need economic demand. So some of the things I've looked at of there's space-based manufacturing, there's different medicines and protein crystal growth, and there's Z-band fiber optics. There's some of those things that can be done in space. There's looking at different cultivars that could grow in space and then be brought back. So I think there's a lot of research going on and should continue on what can the extreme environment of space be used to make things in a unique way that we can't do on Earth and bring it back to Earth. The other one that I still hope for, and some people are investing in it, is space-based solar power. There are places that on Earth where it's still hard to get electricity. There's places on Earth that could benefit from a lot more electricity than they have, like folks who want to do water purification, where space-based solar power, maybe they would be willing to pay more per kilowatt hour because they would get pure water, and pure water can actually lift a lot of local economies out of poverty if they have fresh water and they don't have to spend all their time looking for water, and can improve agriculture. So if governments can invest in it, that's fine. But I think there has to be, just like when the railroad went out, there has to be a regular, normal economics that bring a reason for people to be out there and a reason to go there. And then there's a return that keeps sustaining it. So I think space-based solar power might be one of those, as a clean energy, and getting that energy to different parts. But there's a lot of people with a lot of ideas, but creating economic demand, I think, makes it more sustainable than just governments choosing to spend a small part of their gross national product on it.
Yeah, that makes a lot of sense. Yeah, like identifying those use cases that can actually deliver some sort of return on investment in the short term, and not too risky of a way. Yeah, I think that what we're seeing too is that like we're almost trying to come up with excuses to finance like some of this stuff that's just cool.
Right, right.
But I wonder, you know, if people would be willing to just do it only because it's cool. Like we should be maybe it's so big of an economic return, but it's like, you know, there's a lot of surplus capital that's kind of, you know, being allocated and moving around on or not so cool things or
Right.
not so interesting things. So maybe you know, if we can lobby, especially older individuals that have, you know, a lot of maybe you know, they want to spend their money in a charitable way to get humanity off planet or to become multiplanetary.
Yeah.
Yeah, that's
Well,
the
the other thing that makes it hard is the typical investment that people make. They're looking for a return on the order of 4 years or 5 years or whatnot. But space investments are going to be a longer, you know, 20 or 30-year return, something like that. So that just understanding that and communicating that, that if a person is making investment, it's the long play in space.
definitely. Yeah, it's the proverb, you know, that a society grows, is it grows wealthy or you know, it grows wealthy when the people plant trees in whose shade they won't sit. You know, I think that's, but yeah, it's tricky because our financial system is all based on these shorter return cycles.
That's right.
Yeah. Mm.
Yeah.
Rod, I see your hand up.
Yeah, I just want to jump in and add that definitely that one of the biggest challenge, and I hope that um, with all the capabilities that emerge in finance in the last year, there'll be found really interesting ideas to fund activities like space exploration. One of the cool initiatives is actually dedicating a portion of deposit money to fund public goods, and there is an example called the Octant app. They dedicate a portion of income received from staking Ethereum to fund public goods. So um, it would be cool to promote space exploration among people who does such activities to get another source of funding for space-related projects.
Yeah, and a lot of times you need that initial capital just to kickstart things that can then, you know, fund itself later.
Totally. Yeah, just planting the seed. Um, yeah, I wonder is so you're working currently right now at space exploration technologies, and I'm curious what sort of problems are you working on right now that are most exciting to you? Anything that you'd like to share with us?
Yeah, sure. Yeah, actually, it's space exploration engineering because it's very
Sorry.
closely named. um, no worries. I see. Yeah. So we've got several projects we're working on. As you mentioned early on, working on several lunar missions and some lunar commercial missions. So those are very, very exciting. We're also working with several missions that are now using solar electric propulsion and, you know, ion engines, which is really fun for me because that was my high school senior honors project, was electric propulsion. Well, rocket propulsion in general, but electric propulsion was a dream. So it's been really fun to do that. And so that's the orbit mechanics for that are just crazy different than when you have high thrust maneuvers. And most of my career has been doing chemical engines, high thrust engines, and so we've started working on different ways to plan low thrust trajectories from one orbit around the Earth to another orbit around the Earth, like for communication satellites or to geostationary, but also to go from the Earth to the moon is really challenging because it's pretty straightforward of how to get out to the distance of the moon, but then how do you rendezvous with the moon, get the timing right, and capture an orbit around the moon? So that's been, I don't have another word for it than fun. That's just been really fun to learn how to do it, to go through the research, working with some folks who in our company have just done an amazing job in figuring out how to do this. So I'm learning a ton, and whenever I learn, it makes it funner for me. And then the other thing that we do is a lot of training. So we're a small company. We're only like 17 people. So we're not trying to get big contracts to do the work for other folks. What we do is we work with commercial companies that want to learn how to fly satellites. And I think one of the most rewarding things that we do is we train folks on how to do that. We train them to be an astrogator. We give courses on how do you plan a maneuver, how do you plan a trajectory, how do you track a satellite. And it's just so cool working with these groups. They bring in their own unique perspective, their own experiences. All the spacecraft they're working on has their own crazy requirements that they're trying to do that I've never seen before. And we go through a training process and then a workshop process and figure it out. And it's just been really rewarding seeing new folks enter the field and then become experts and then be ready to support operations and then actually fly this. So we went through a long time for years training and working with the South Koreans for Danuri, and their spacecraft's orbiting the moon now. And it's just so rewarding to see that. And we've built some great friendships along the way too. And so that's always fun.
Yeah, that's awesome. I'm really curious about this new propulsion technology that you mentioned. So you said it was solar ion thrust?
Okay. Yeah, so it goes, most people call it solar electric propulsion and some people call it ion propulsion. But basically, you're, rather than taking chemicals like, hydrazine and an oxidizer and creating flames and whatnot, you can take gases like xenon, or you can take solids like iodine, or even water, and you can ionize them and shoot them out the back of an engine extremely fast, much faster than the flames come out. Typically, flames might come out at like 3,000. Am I getting this right? 3,000 meters per second. And the ions might be coming out at like 30,000 or 300,000 meters per second, 10 to 100 times faster. They don't give as much thrust, so you're not going to use this to lift off from a planet, but they become very efficient in terms of, let's call it miles per gallon. They become very efficient. They don't use as much propellant to change the orbit. But a normal maneuver that you would take like 2 minutes with a chemical engine might take 2 days with an ion engine. So it's going to the moon might take months rather than days. So there's trade-offs. It's more efficient. You're not using propellant. Your spacecraft can be lighter, but it's going to take longer to get there.
Yeah, that makes sense. Why is it called solar?
Because you're getting all your electricity from the sun. So you have big solar panels out there charging your batteries, and then using that to ionize and accelerate your ions out the back end. So you're using the sun's energy, which there's plenty of, to do, and then converting that to electricity and using that.
That's incredible. Okay. Yeah, that's really, really interesting. So you can literally use the sun's energy in order to navigate.
Yeah. Yep.
I can see why that's so cool.
It is. It's really cool. Yeah.
And you were working on this back in high school.
Yeah, in high school, I did a honor senior science project on rocket propulsion, And I just went through and studied all these different types of rocket engines. And that was the one that just caught my imagination, was the just, I think the one I was looking at in high school was cesium, was throwing cesium out the rear end of a spacecraft super fast. But xenon is the one that's often used now. I think that although xenon's really expensive, so people might be moving. In one of the conferences I was just at, they were showing iodine as one of the ions they were making. But people have proposed mercury and all sorts of different things.
Yeah, that's super cool. Yeah, I mean, it makes sense, especially for these very long trajectory missions. You know, like if you're already traveling for months, say to go to Pluto,
Right.
then
Yeah.
adjustment over a long period of time. Very cool. All right. Well, we're right over the hour here, so I think we should probably start thinking about closing this up. But I'd like to thank you again for taking the time, and yeah, I feel like, well, I learned a lot. I hope people in the audience learned a lot too. Um, I would like to mention two things before we go. One is that we still have seats available for a zero gravity flight that we're doing with Nicole Stott, Doug Hurley, and Charlie Duke, who walked on the moon. And we're doing that in Houston, October 27th and 28th. So if you're in the area and you'd like to join us, definitely reach out. And then also, we are going to be raffling off a Blue Origin seat to go to space, and between all of our members. So we'll be announcing that very soon. And if you'd like to get involved or have a chance of being selected to go to space, you can go to join.moondao.com to join our community and have a chance of being selected. So yeah, two really exciting opportunities. But yeah, John, this was awesome. I learned a ton, and yeah, really curious. Hopefully someday Moondao will be in one of your training classes, and we'll be learning how to navigate a little bit with one of our own satellites. So
Cool.
thank you so much.
Thank you very much for having me. I really enjoyed talking with you.
Awesome. Thanks, everyone. Bye.
Bye.